Lesson 7 is on rates and average and measures of central tendency. So the first part talks about rates. A rate is a division relationship between two measures. We usually express a rate as a unit rate. And anytime you hear the word unit in math, it means that that number's 1. So which means that the number of the second measure is 1. Here are some unit rates. So 65 miles per hour. So remember they said that this is a rate is a division relationship. Well, the division comes from per. Anytime you see the word per in math, it's division. If you see the word of in math, it's multiplication. So 65 miles per hour means 65 miles divided by 1 hour. So 65 per 1 hour. Or 25 miles per gallon. 24 miles per 1 gallon. 32 feet per second would be 32 feet divided by 1 second. Or 15 cents per ounce is 15 cents. Whoops. Per 1 ounce. Rate problems involve the two units that form the rate. So you can go backwards, and if you were to multiply the number of hours times 65 miles per hour, you would know how far you've gone. So if somebody travels 65 miles an hour for 1 hour, 65 times 1 would tell you they went 65 miles. If someone travels for 2 hours at 65 miles per hour, then 65 times 2 would be 130. They'd go 130 miles. Number of gallons times 24 miles per gallon would give you the number of miles, and so on. So the first one is an example like we just talked about. Driving at an average speed of 55 miles per hour, about how far will the driver travel in 6 hours? So I like to write this in the way that we did with the unit conversions. So I would take 55 and I would write miles per hour as miles per 1 hour. Okay, so I would actually write that out as the division problem. And then how far would they travel in 6 hours? Well, then I'm going to take times 6 hours. And since they didn't tell me anything else, it's going to be just over plain old 1 like we did in the conversion problems. Remember, in conversion problems, when units are diagonal and they're the same, they'll cancel out. So I'm going to be left with miles as my units in the end. So I'm going to do 55 times 6. So 5 times 6 is 30. And then 5 times 6 is 30, plus 3 is 33. So that would be equal to 330, and then remember my units are miles. The way they do it, just using the formulas that they had on the first page there, that the number of hours times the miles per hour equals the number of miles. I like it this way because you can visually see that hours are canceling out and that your end unit is going to be miles. Otherwise, sometimes you might get confused and try and put down hours for your units, but if you're talking about distance, that wouldn't make sense. Heather finished the 100-kilometer bike race in 4 hours. What was her average speed in kilometers per hour? So kilometers per hour tells us that we want our final units to be kilometers divided by hours. The per means divided by. So that tells me I'm going to take the kilometer number that they gave me in the problem, and then I'm going to divide that by the hours number they gave me in the problem. So 100 kilometers divided by 4 hours, I haven't crossed any units out, so these will both be there in the end, which matches the units that I want, kilometers per hour. So 400 or 100 divided by 4 is 25, and then the units are just like they are shown here, kilometers per hour. Okay? Or you could write it as they do right here, kilometers per hour in words. Traveling at an average rate of 58 miles per hour, about how long would it take a car to travel 20 miles? So in this one, they're asking for an estimation. So if you think of it in terms of minutes, 58 is close to 60 miles an hour, which means you're going to go a mile a minute. And so then it would be about 20 miles because they've traveled, or excuse me, about 20 minutes because they've gone about 20 miles, a mile a minute. But since you're going slower than 60, it's going to take a little more. So that's kind of a tough distinction to make. The other way that you could do it is to say, actually figure it out, and you'd have 58 miles per 1 hour, and then you'd multiply, and we have 20 miles here. Oops. And I need to have, and I can already see that I've made a mistake because if I want hours to be my units in the end, they'll need to be on top. So I'm going to redo this and write the other fraction that says it takes 1 hour to go 58 miles. And then I'm going to multiply by 20 miles, and I know that needs to go on top because miles is on the bottom in the first one. And now that I have hours not crossed out and it's on the top, I know I've done this correctly. So basically what I would do is take 20 and divide it by 58. And if you do that on a calculator, you get 0.3448, and this is in hours. Now, I don't typically think about things in hours like that, so I would then take 0.3448 hours, and I'd convert that into minutes by saying times 60 minutes on top and 1 hour on the bottom so that my hours cancel. Okay, more usefulness for conversions, which was lesson 6. So then if I multiply that by 60, that says that it's about 20.7 minutes. So just over 20 minutes, almost 21 minutes. But again, having that estimation skill is pretty important. If I'm going 58, 55, I know I'm gonna be going almost a mile a minute, a little bit slower. So in examples 1 through 3, we use the term average speed. The speed of the truck in example 1 probably fluctuated above and below its average speed. However, the total distance traveled was the same as if the truck had traveled at a steady speed. So if you think about driving, you're not always going to be going 55 down the highway. Sometimes you might be going 40, sometimes you might be going 70. But averaging out the distance and the time is how we calculate that. In common usage, the average of a set of numbers is a central number that is found by dividing the sum. So you take and add up all the numbers, sum means addition, and then by the number of elements. So you add up all the numbers and divide by how many numbers there are. This number is more specifically called the mean. So you might want to add that to your notes. Add up all the numbers and divide by how many numbers there are. The big thing when you're doing this is on your calculator, if you're adding them up, you need to either put them in parentheses before you divide or push enter on your calculator before you do the division. Otherwise, the calculator is going to do order of operations, which means division goes first, and then it's going to add things on, and you're going to end up with the wrong answer. Calculating an average often involves two steps. First, we find the total by combining, then we make equal groups. As an example, consider these 5 stacks of coins. There are 15 coins in all. Find the average number of coins in each stack is like leveling the stacks. So if I took 2 off of this stack here and put it over here, then both of these stacks would have 3. And then if I took 1 off of this stack and put it here, then all of the stacks would have 3. So 15 divided by 5 stacks tells us that there's an average of 3 coins in each stack. Referring to the original stacks, we say the average number of coins in each stack is 3. And you can see that they're adding up all the numbers. And then there's 1, 2, 3, 4, 5 stacks. So then they took that 15, the sum of them, divided it by 5, and this number then is our average. In the 4 8th grade classrooms at Keeler School, there are 28, 29, 31, and 32 students. What is the average number of students in an 8th grade classroom at Keeler School? So the first thing that you do to find the average is you add the numbers up. So 28 plus 29 plus 31 plus 32. So I would look at this and I'd say, well, 28 and 32 make 60, and 29 and 31 also make 60. So there are 120 total students. And then you take that number and divide by how many classrooms there are in this case. So 120 divided by 4. And that's going to be 30. 12 divided by 4 is 3. 120 then is 30. So there's an average of 30 students in each classroom. Now there's not 30 students necessarily in each classroom, but if you kind of spread them across and make them all even, that's when you would have the 30. So thinking skill. Without calculating, could we predict whether 35 is a reasonable answer for this problem? Well, if we hadn't already calculated it, look at the numbers. You have 28, 29, 31, and 32. So one thing that you should notice about all 4 of those numbers is that they are less than 35. And the mean, if you go back a page and look at the definition, is it's a set of numbers is a central number. Central number means it's in the middle of the numbers. So if I go forward, is 35 in the middle of 28, 29, 31, and 32? No. So one very easy check for whether you've done the correct calculations is your mean needs to be in the middle of all your numbers. It at least has to be less than some of your numbers and more than some of your numbers. So 35 would not be reasonable because it's not in between. In fact, it's bigger than all of the numbers. The average or mean is one measure of central tendency. So like we just talked about, it's in the middle. Other measures include median, which is the central number of data, and the mode, which is the most frequently occurring number. To find the median, we arrange the numbers in order from least to greatest and select the middle number or average of the 2 middle numbers. So if you have an odd number of numbers, it will just be the central number, the middle. If you have an even number, you'll have to find the average of the 2 middle ones that you have. To find the mode, we select the number that appears most often. Below we show the prices of new homes sold in a certain neighborhood. Find the mean, median, and mode of the data. Which measure should a researcher use to best represent the data? So To find the mean, we add up all the numbers. So we're going to take 170 plus 208 plus 185 plus 209 plus 181 plus 183 plus 191 plus, and you can be doing this on your calculator as we go, 175 plus 175 plus 187 plus 195 plus 219. So if I add all those up, I get 170 plus 208 plus 185. See if you can beat me. So I get 2,278. And then I go through and there's 1, 2, 4, 6, 8, 10, 12 values. So I take that number and divide it by 12. And get 189.8. Well, 8333 repeating. So, and then I'd look at all these numbers that I have, and since none of them have decimals, I would round it to the ones place. Remember, the squiggly equal sign says it's about equal to. It means I'm rounding. So I would call that 190. The 8 rounds this 9 up to a 10, which makes this 8 turn into a 90. Now, to find the median and mode, I have to put the data in order. So I would do the lowest number, which looks to be 170. And I like to cross them off as I go so that I don't miss a number. And then I think 175 is the next. And there's another 175. And then the next lowest is 181 and 183. 183. And then 185. And 187. 191. 195, 208, and 219. And then I like to go back through and count how many numbers I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops, I missed 209. So there we go. So 209 and then 219. Now I have 12. So that's a good check to see that you've gotten everything you were supposed to. So now to find the median, I'm going to work my way from each side. And you can do this with your fingers. I'm going to cross them out. So I cross one off from the low end and one off from the high end. And then I cross one off from the low end and one off from the high end. And I'm working to find that middle number. Okay? So like I said before, if you have an even number of numbers, you're going to end up with two numbers in here. Well, the median is the number that's directly in between those two numbers. And the way that we find that is we find the average of 185 and 187. So we would take 185 plus 187, and then we would divide that by 2. So 185 plus 187 gives us 372. And then we divide that by 2. That's 186. Okay, so the median is 186. The mean is 190. And then the last one is the mode, the number that happens the most. And so looking through this, I see that there are two 175s. So I know that that is my mode. So here's how they went through and solved things. Added them all up, divided by 12, came up with a mean of 190, which is what we got. They put the numbers in order and found that the median was between 185 and 187, so they used the mean of those two numbers, added those up and divided by 2, and got 186. They also found that 175 was the most frequently occurring number. It had 2, every other number only had 1. So then if the researcher is reporting to someone interested in property tax revenue, the mean is a good statistic to report. It may be useful in predicting revenue from property taxes. So when someone goes to buy a house, they typically look at what the mean property value is around the house that they're wanting to buy, because then they can kind of think about, well, is this a good price for this house or not? If the researcher is reporting to prospective buyers, the median is a good statistic to report. It tells the buyer that half of the new homes cost less than $186,000 and half of them cost more. The mean may be misleading to a buyer. Its value is greater than the median because of a few expensive homes. Only 1/3 of the homes were sold for more than $190,000. So, a couple of things to think about there. We may also refer to the range of a set of data, which is the difference between the greatest and least numbers. So that's an important definition to know. So the range of home prices, you take the biggest, 219, subtract the smallest, 170, and the range is 49,000. The range basically tells you how close together all the data is. If you have a really big range, the data is not very close together. If you have a very small range, it's pretty close together. So the practice. Alba ran 21 miles in 3 hours. What was her average speed in miles per hour? So if I write miles per hour in math, it's miles per hour. So that tells me that I'm going to take the number that they give me for miles, 21, and then I'm going to divide that by the number they give me for hours, 3. 21 divided by 3 is 7, and this unit right here stays as it is, miles per hour. How far can Freddie drive in 8 hours at an average speed of 50 miles per hour? So if I write 50 miles per 1 hour, they ask me how far, so I know that I want miles on top, and then times 8 hours, because then the hours will go away, over 1. Well, 50 times 8, there's 2 50s and 100, so that's going to be 100, 200, 300, 400. And then our units are the ones that aren't crossed out yet, and that's miles. If a commuter train averages 62 miles per hour between stops that are 18 miles apart, How many minutes does it take the train to travel the distance between, about how many minutes does it take the train to travel the distance between the two stops? So this is like the example problem where they were going 58 miles an hour, which is close to 60, which is 1 mile a minute. So 62 is also close to 60. So a mile a minute would mean they're going to go about 18 minutes. But since they're going faster this time instead of slower, it's going to be a little bit less than 18 miles per hour. Or excuse me, less than 18 minutes. So 62 miles per hour is close to 60 miles an hour. That's 1 mile per minute. So if it's 18 miles apart, then it takes them about 18 minutes. But since it's going faster, they're going to get there quicker than if they went 60 miles an hour. So it's going to be a little bit less than 18 minutes. If the average number of students in 3 classrooms is 26, and one of the classrooms has 23 students, then which of the following must be true? At least one classroom has fewer than 23 students. At least one classroom has more than 23 students and less than 26 students. At least one classroom has exactly 26 students. Or at least one classroom has more than 26 students. So one thing to remember is that average is the middle number. So like I was saying before, if you find the mean, it has to be in the middle of all of your data. So we know that if I have one that's 23, which is less than 26, I also need to have one higher than 26 to kind of balance that out. So at least one classroom has fewer than 23 students, that's not going to work. At least one classroom has more than 23 students and less than 26 students. We're not sure. It could be possible. At least one classroom has exactly 26 students. Again, we're not sure, but it could be possible. But at least one classroom would have to be more than 26 students. That one will work. These two could happen. They don't have to happen. This one must be true. All right, what is the mean of 84, 92, 92, and 96? So add the numbers up. 84 plus 92 plus 92 plus 96. Is 364. And then you take that number and divide by 1, 2, 3, 4 numbers, which is 91. Now, I want to check, does this make sense? 84, 92, 92, and 96, is that in the middle of all 4 of those numbers? Yeah, it is. You might be surprised that it's less than 3 of them, and the reason for that is that 84 is so low, it's pulling that average down lower. The heights of 5 basketball players are 184 centimeters, 190 centimeters, 196 centimeters, 198 centimeters, and 202 centimeters. What is the average height of the 5 players? So you add the numbers. You get 970, and then you take 970 and divide that by 5 basketball players, and get 194 centimeters. Since all the other units were centimeters, this one will be as well. Price per pound of apples sold at different grocery stores is reported below. Use this information to answer problems G through I. Display the data on a line plot. So what that means is So I would go, yeah, $0 all the way up to $3. So 1, 2, 3. Whoops, 1. So 99 cents would be right here. 199 would be over here. 149 would be about here. 199, we got another one. 149, we got another one. 99 cents, we got another one of those. 249, and then 149, we got one more of those. Compute the mean, median, and mode and the range of the data. So using our number line, we can kind of see the order that these have. So the mode is clearly the 149. Sorry, that's tough to read. Okay, the range, the highest one is 249. The lowest one is 99 cents. So the difference there is 150. So that's the range. The median's the middle number. So if I write them in order from biggest, least to greatest, so 99, 99, 149, 149, 149, 199, 199, and 249. So I cross off from each end until I get either 1 or 2 in the middle. And I have two 149s in the middle. And you can do the average of those two if you want on the calculator. You would do, I'll come up here. You would do 149 plus 149 divided by 2. And you should end up getting 149. The thing is, if you have two of the same number in there, the number that's directly in between them is that same number. So the median is also 149. And then the last thing to do is find the mean. So we're going to take 99 cents plus 99 cents plus 149 plus 149 plus 199. Oops, 149, one more of those. Plus 199 plus 199 plus 249. So I end up getting 1292. And 1292 divided by 2468 is 1.615. And again, I'd look and all of the rest of them are rounded to the hundredths place. So I would round that to 162. Last problem. Rudy computed the average price and predicted that he would usually have to pay about $1.62 per pound for apples. Evaluate Rudy's prediction based on your analysis of the data. So if he says he would usually have to, that's not entirely true, because the most often would have been $1.49. So yeah, the mean, the average is $1.62, but more stores sell them for $1.49 than that. So I would tend to say that this is not true, that Rudy will often usually be paying $1.49. Another thing to look at, kind of like with the house, is that all of these points here are less than 162. So more stores sell it for less than 162 than sell it for more. So more stores sell apples for $1.49 per pound or less than sell for $1.62 or more. So he will not usually pay $1.62. In fact, no stores sell them for $1.62, so he's not going to be paying $1.62 at any stores.